My name is Bhargav and welcome back to my YouTube channel. So today we're gonna learn about one of the important topics of design and analysis of algorithm, that is performance analysis of an algorithm. So topics covered under this presentation are introduction to performance analysis, performance dependency, usage of computer memory, space complexity, examples of space complexity, time complexity, and finally examples of time complexity. Performance analysis. Performance of an algorithm is a process of making evaluative judgment about algorithms. Performance of an algorithm means predicting the resources which are required to an algorithm to perform its task. Performance analysis helps us to select the best algorithm from multiple algorithms to a problem. That means we have multiple algorithms to solve a problem. We need to select a suitable algorithm to solve the problem. We compare algorithms with each other which are solving the same problem to select the best algorithm. To compare algorithms, we use a set of parameters or set of elements like memory required by the algorithm, the execution speed of that algorithm, easy to understand, easy to implement, and etc. Generally, the performance of an algorithm depends on the following elements: whether the algorithm is providing the exact solution for the problem, whether it is easy to understand, whether it is easy to implement, how much space it requires to solve the problem, how much time it takes to solve the problem, and etc. When a program is under execution, it uses the computer memory for three reasons. They are as follows: instruction space. It is the amount of memory used to store compiled version of instructions. Environmental stack. It is the amount of memory used to store information partially executed function at the time of function call. Data space. It is the amount of memory used to store all the variables and constants. What is space complexity? Space complexity of an algorithm can be defined as the total amount of computer memory required by an algorithm to complete its execution is called as space complexity of that algorithm. When we design an algorithm to solve a problem, it needs some computer memory to complete its execution. For any algorithm, memory is required for the following purposes: to store the instructions, to store constant values, to store variables, and a few other things like function call, jumping statements, etc. If any algorithm requires a fixed amount of space for all input values, then that space complexity is said to be constant space complexity. Consider the following piece of code. Example: int square int a, return square value of a. In the above piece of code, it requires 2 bytes of memory to store variable a, and other 2 bytes of memory is used to return a value. That means total it requires 4 bytes of memory to complete its execution, and these 4 bytes of memory is fixed for any input value of a, and the space complexity is said to be constant. If the amount of space required by an algorithm is increased with the increase of input value, then that space complexity is said to be a linear space complexity. Consider an example. In sum, under the argument an array of integer type and a variable of integer type, int sum is equal to 0, and we have declared a counter variable I which is of type int. For I is equal to 0, I is less than I plus plus sum is equal to sum plus a of I return sum. So this function will return the total summation of every value which is being stored in this array. So here the space complexity for sum is what we call what we call constant. For sorry, but when we come to loop, when it comes to loop, so we'll be storing values in the stack during the execution time for every iteration. So the space, what we call the space occupied by this statement, will be known as linear space complexity. In the previous code, it requires n into 2 bytes of memory to store variable a, 2 bytes of memory for integer parameter n, 4 bytes of memory for local integer variable sum, and I, 2 bytes of memory for 8 return value, sorry, each return value. That means totally it requires 2n plus 8 bytes of memory to complete its execution. So here they have said, so sum and I will take 2 bytes each, means the local variables of this function sum and I will take 2 bytes, return value of sum will take 2 bytes, so 2 plus 2 plus 2 is equal to 6. So another updated value sum is equal to sum plus a of I, even that will take 2 bytes of what we call memory. So totally 8 bytes of constant memory it will be consumed. And as I told, during the execution of for loop, values will be stored iteratively in the stack. So for n elements of array, n amount of bytes will be allocated. So total time will be 2n plus 8. That means totally it requires 2n plus 8 bytes of memory to complete its execution. Here the total amount of memory required depends on the value of n. As n value increases, the space required also increases proportionally. So what we call n here, n is related to array. So n is known as number of elements which is stored in array. So if I increase the number of elements in an array, so the number of iterations will also increase. As per the number of iterations, number of elements which is been stored in stack during execution will also increase. So here as PPT says, n value, as n value increases, the space complexity will also increase. If I increase the number of elements in array, so the space complexity will also increase linearly, because these two what we call units are linearly directly proportional to each other. If I increase number of elements, so the iterative, so according to the iterations of for loop in this example, number of elements which is being stored in stack during execution will increase. So due to that, obviously the time complexity will increase. This type of space complexity is said to be linear space complexity. What is time complexity? The time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. So the time complexity is nothing but the total amount of time taken by an algorithm to complete its execution. The running time of an algorithm depends upon the following facts, or what we call factors: whether it is running on single processor machine or multi-processor machine. So if any algorithm is running in single processor machine, then all the process will depend on that particular single process, so time taken will be more. Why? Because every single instruction will have its own priority. So due to that priority, you may face misorder or disorder of execution of instructions, and you may not complete the execution of algorithm up to the what we call expected time. If we have processor machine, so we can divide our instruction or algorithm, and we can what we call share the divided instruction for um, n number of processors. If I have for example, if I have 4 processors and I have 4 instructions, so each instruction will be carried out by each processor. So time complexity will be decreased because the number of processors are increased, and processing speed is also increased, and total processing time is decreased, whether it is a 32-bit machine or 64-bit machine. read and write speed of the machine, the amount of time required by an algorithm to perform arithmetic operations, logic operations, return value and assignment operations, input data. So mainly the input data will affect the time complexity. The number of input is directly proportional to the time complexity. If any program requires a fixed amount of time for all input values, then its time complexity is said to be constant time complexity.